Good afternoon, everybody. Welcome to our webinar, which we see as the guided tour through RCA. You have registered for 260 people, more or less, but we expect that 60, well, there are already 70 people, and the number is running up joining us, so welcome. Please be aware, this is also, of course, for the presenters, that the meeting is being recorded, so everything you say can be used against you. Be careful on that. But for those who are attending, your chance to talk is only at the end of our webinar when we have the questions and answers session. My name is Michel Russen. You can see it on the background, so it's easy to remember. And I am the managing director of the users group. I will share for you for a minute the agenda which we have for the webinar. Hold on a second. It should be visible now. Is that correct? I guess so. Then what we will do is in a minute, but not before that, Stefan Schmid will start with explaining the background of RCA. I would say this is why RCA. Then we will have a presentation of Davinda Bhatia about the architecture structure, followed by a presentation of Frank Skoran about the document structure. And these two are basically the what is in RCA. Then Oliver Lemker will explain about the methodology, the how of RCA. And well, those are interesting things, but of course, also the future is important, and that is about the transition to the Europe's rail system pillar, which is what's next for RCA. And after these presentations, you will be in a position to ask your questions, and hopefully we can then provide you with answers. You see in the background of this picture two logos, one from EU Links and one from the ERTMS users group. And maybe I am allowed from Stefan to take a little bit of his RCA part by saying that RCA is an initiative of EU Links and the ERTMS users group. This started in 2017, when at a certain moment we in the ERTMS users group discussed about that the deployment of ERTMS looked a great idea, and it is a great idea, but putting ERTMS just in existing systems is only leading to very costly systems, and that was the reason why we said we have to make a further step by going towards a reference architecture, and that is the reason why it is called the reference CCS architecture. And in 2017, the two organizations, EU Links and the ERTMS users group, and I think I speak also on behalf of the technical lead of the EU Links organization, Mirko Blazic, we entered into an agreement, a letter of intent, and that was the start of this initiative of RCA. So maybe that was a little bit of a pre-thing, because I know that Stefan is going to talk a little bit more about the content. And you have heard enough from me for now. I give now the floor to Stefan. Stefan, can you please take over?
Thanks a lot, Michel. So I'm sharing my screen. So yeah, RCA, where it all began. As you already heard, we have started in the year 2017. And just to recap shortly, in what situation we were at that time, we all were, or many railways were successful in already installing level 2 lines, ETCS level 2 lines. Many were in large programs for the deployment plan. And both groups, ERTMS user group and also the railways of EU Links, we discussed together how we could optimize the overall situation. And the point is not that there were, let's say, technical problems. It was more about the question, how could we go on? How could we even put more business case on the whole situation? How can we improve the situation? And so we had this strategic analysis of the situation overall. And the basic conclusion out of this analysis was that the biggest point, especially to implement the so-called game changers. Game changers at that time were a certain list coming from a sector agreement that was done, a memorandum of understanding, like ATO, like moving block, like mobile localization, for example, braking curves, FRMCS. So everything that brings the whole CCS system to a higher performance and to lower cost, especially, for example, a big target in the cost reduction was reducing the number of trackside assets, or of course improving capacity in terms of making use of level 3 or other stuff. So we had a discussion how to do it, but when we came to that discussion, we found out, or we made an overall view of the, let's say, improvement speed that the CCS has in the sector, and we found out that we are not really fast enough, I would say. Many things were achieved, but even small changes in the TSI or in the architecture, adaptations to the product market, everything we did took a long while. Everything, of course, is influencing the installed investments, and we, of course, have to assure the safety of investments. So simple question was, how can we be more flexible, faster, and more efficient in the development of the overall system? And this was an alignment that got very fast. Everybody was standing behind the idea. Of course, we have to improve. But now the question was, okay, what do we have to do? Because just saying we put more money to the development is one thinking, but that does not reduce complexity. And we have to reduce complexity on all sides. It's on the product development side, on the railway side, and the asset management, in managing the life cycle, managing the skills. So everywhere we have to make things more simpler, or you can also say more industrial. And this was the basic idea to solve, or the basic idea to go on. And the solution for that, to come to that, was, as Michel already explained, a reference CCS architecture, which means a reference how to optimize. And the basic idea behind that in the beginning was that we, of course, need to have a much better business case. We, of course, this is always the story, but we want to improve the deployment speed. And this means the deployment should have a much higher payback. We should give more assurance to the investors that what they do, for example, on the vehicle side, is really upwards compatible, that it is safe for a long time, can be upgraded so that he is willing to invest and to connect. We need simplification of the project processes, which at that time needed already still a lot of skills and manual management. And it got very clear that the main driver of that complexity is the huge number of variants, of implementation variants, especially radio-based ERTMS, that drove the, let's say, that were covering the capacity in the market that we have, either in the, on the one hand on the railway side, on the other hand also on the supplier side. So too many single variants means too many different things to support, to develop, to do, and having even per country sometimes more than one variant how to implement leads to 50 different implementations instead of one. And this factor 1 to 50 means, of course, capacity is over, and then we can do nothing. Then the other point was, of course, we need a simplification of skills, so skill needs. So the quality of the products, or the architecture, or the implementation of the railways should make it simpler to maintain. And last but not least, as you all know, radio-based ERTMS, when we talk about the game changers, is able in principle to be as performant as CBTC, high-tuned urban systems or other systems, because radio-based control systems are able to do that. But up to now, the architecture is not taking is not capitalizing fully this possibilities, because what we did in the past was a little bit a mixture of old and new. And so we want to clean up a little bit and, let's say, get the full potential out of radio-based ERTMS. So these were the ideas, and we wrote a white paper, and 2 years later, even the UNIFE steering committee agreed to the problem statement. Of course, not with an already precise solution, but in general, the problems were clear on all sides. And the basic picture that we generated at that time was this one. It was describing all the different architectures in the countries, more than 50, by the way, where you, as a, for example, product supplier, cannot have one product that you sell everywhere the same way. And this means you have to have a lot of investments per installation. And this means you do not want to invest much into development. This means you do not have a high grade of automation. So the payback is just too low. And when we switch over to the idea of layering the architecture, of having standard elements and competition per layer and not for the full configuration, that somebody is really able to sell one product in 10, 15 or 20 countries or companies, railways, then of course we get the payback to amortize higher level developments, and we also get a simplification of the complexity very fast. So this was the basic and starting picture. Of course, we always used the example of USB at that time, which is yeah, let's say 90% good analogy, but it's clear, you know, you all know that when USB came to the market, how it flushed the whole market and new products came out, new developments came out just by simplifying and decoupling, for example, computer and devices. And this was an input to the market. So this was the basic idea. So our targets were clear. We wanted to generate a modular and upgradable system, standard interfaces, a building block idea that can be combined out of standard layered systems, and a scalability that is coming from the building blocks. Of course, the cost reduction coming with a less physical assets, so implementation of the game changers, and a long living architecture where we can replace in modular way. So these targets were written down and are still the same up to today. So I'm very happy that we have now the release 1.0. And yeah, and my colleagues now will show what is in there.
Thank you, Stefan. So now that we know the why of RCA, the question is, of course, what came out of it? And we start with, I would say, the high-level results on that. I give the floor. I'm happy to give the floor to Davinder Bhatia, who will explain you the architecture structure. Davinder, the floor is yours.
Hello, good afternoon, everyone. I'm just going to share my slides very quickly. Hopefully you can see my screen. Let's go into slideshow.
Yes.
So yeah, thank you, Michelle and Stefan. So the next 15 minutes, I'm going to talk about the architecture structure and explain a little bit about the context and scope and what that means, and then move on to the functional architecture, and then finally the system architecture to try and describe and explain some of the ideas around the architecture. So the first thing is based upon the RCA white paper that Stefan mentioned and the objectives. This was the foundation of the need, and RCA defines information that allows people to or enables them to build a system to meet those needs. Initially, the focus was on trackside, but I'll talk a little bit more about that later, and what the infrastructure manager's requirements were or are, and then try to establish what was common, and to be able to have that generic functionality that can be reused across different railways, as Stefan mentioned. So the green boxes show standardized functions and processes, and the grey boxes shows things that weren't standardized and that weren't common, and they are different in each locale or country. So the key area of focus initially was around everything needed to safely control movements and understand restrictions on tracks. And then there are generic functions, which I'll talk about later, considered to be supporting functions, and they can be reused by the green functions inside RCA's scope. But always remembering that the foundation is radio-based ETCS and reusing existing standards. A couple of other things to think about. Not all implementations have the same priorities. So the solutions need to be flexible, even though they're based on this reference architecture. And the platform needs to be evolvable so that, or the solutions need to be evolvable so that they can be enhanced without resignaling or access to the track. And that's extremely important in terms of saving cost and also time and all of the safety validation and verification. So now moving on to the functional architecture, we're going a little bit deeper into those greener boxes. And as Stefan said, the layered approach is really important to make sure that we understand that functional separation. And the green boxes are what's in scope, and try to understand exactly what's needed to meet those needs. I'm not going to talk about the boxes because we don't have time, but just highlight a couple of areas. So the first area is the layered approach gives us an opportunity to use well-defined interfaces. So for instance, in terms of in the middle, you have device and object abstraction. What that allows us to do is to abstract the functionality from the physical devices. So that gives the functionality device independence. That's extremely important when you think about FFIS and physical interfaces, which is what we want to minimize and possibly have a virtualized runtime environment for this functionality. Okay, then minimize the safety critical functionality and logic and making that generic. So what that means is the safety functions are the same, but they don't change when they're in operation, and using a proven design which has a safety case. So they're really important aspects of this layered architecture. We then have common functions on the right-hand side, and they're reused by the other functions within the layers. So for example, we have a safe topology, which has the same geometric map data, and that can be used by all of these different functions. Another example is identity and access, which can also then be used by different functions, which isn't the case today, as you may be aware with things like ATO and ETCS. So now going on to a little bit deeper, we have the same layers in this slide, and this is a system architecture slide, and is actually showing not just systems, but subsystems. And just a couple of things about this slide. This is one of the key RCA outputs. This structure was defined by a systems engineering approach, which Oliver will explain later, but takes into account the architectural drivers, viewpoints, and associated design rules, using viewpoints allowing trade-offs and considering constraints. And this decision-making process is really important, using this methodology to allow us to take into account and break down into these different subsystems. So these aren't just subsystems or subsystems that we've dreamt up. This is more a case of taking a methodology and then using that information to meet those needs and defining these subsystems. So importantly, we have something called APS, or Advanced Protection System, and people may know that Advanced Protection System as the interlocking and RBC in one system, and that's what provides this centralized safety logic, which manages only geometrically defined permissions. And we also have ATO, and has a similar architecture, and using those existing standards and in terms of the implementation may be different using this reference architecture, but in terms of the behavior, you get the same behavior that's defined in the ERTMS standard, including ETCS and ATO. And since defining or focusing on the trackside implementation, we've also had the onboard reference architecture, Acora, and that again has been adopted and integrated into RCA, and I think Frank may talk a little bit about that later. And finally, one example of where we've adopted some certain aspects of ETCS in the latest standard is around localization. So one of the key drivers, architectural drivers, is being able to harness the explosion of data with intelligent trains, and trains being able to provide a lot more information about its length and position at a higher granularity, but also being able to use, sorry about that, different types and different sources of localization, and then being able to aggregate that into one piece of information that can then be used by the safety logic. Okay, so that is a very quick run through the architecture structure. I'm now going to pass you back to Michelle, who hopefully will introduce the next section. Thank you.
Well, I can see, David, that you are just in time before you were switched off by Microsoft. Congratulations that you managed to succeed to finalize in time. But if we leave you, we know that it's the fault of Microsoft. Eh?
Yeah, so Microsoft doesn't like me, and I don't like Microsoft. Okay.
Right, thank you very much. You did well in time, I must say. So, Frank, you are in the very lucky situation that if needed, you could take a little bit more. And you told us up front that you need a little bit more time, because I would say that, Davinda, what you showed us, well, looked simple, but there's a lot behind it. And there are loads of documents. And also the purpose of this webinar is to give you an overview of the numerous documents which are there, and to give you a kind of a guide on how can you then access that information which is relevant for you. And from that perspective, I think that the presentation of Frank Skorom, I hope that I pronounce it now in the right way, Frank. It's a bit difficult, but that you can explain and help a little bit on making sure that it is easy to find what people are looking for. The floor is yours.
Exactly. Thank you very much, Michelle. In the meantime, I was looking for a pop-up window saying ready to install RCA, but I could not make it so fast. Anyway, like Michelle said, it is now the presentation to help the audience to better walk through the numerous list of documents, so to know where to start and what is your area of interest. And first of all, the RCA releases are published on that site. So it has a page which you see down there, and at the right bottom corner you see the link to the RCA documents. So there you will find that. So I think this is an easy to remember address, ertms.be workgroups CCS_architecture. We have mainly two bunches of documents, and in focus of our release is this so-called main document set of this release. So these are all the documents which we have presented or worked on in the last time, and which now represent the current state of RCA. Why do I say the current state? We also have the second bunch, which is the supporting documents. And these are documents from the previous releases. So we had alpha, beta, gamma, 0.4, 0.5, if I correctly remember, and now 1.0. So these are documents from these releases before. and they provide contextual information which might be interesting for you. And we decided not to update all of them, so they might not necessarily be up to date. So just as a warning before. These different chunks are available by different download links which you will find. I have tried to relate all the documents by groups, which you can see by the color codes, and I tried to relate them to the architecture as shown by Davinder, and there's also the main architecture poster document, which is RCA Doc 40, where you can find this architecture here. So we will have some overarching documents, let's say some meta documents like for a release. We will have also documents which describe the methods, and you will hear a presentation by Oliver later on. We have documents which are rather architecture related. We have also documents which will present the ideas of the platform, things on localization, which we did together with the ERTMS users group, localization working group, LWG. And then we have, let's say, the functional areas for PE, for APS, for IPM, incident prevention management, for the map, and for ATO. So I start with the first group, these release documents. So we have, I think, the usual things like an FAQ. So it's suggested to read that first if you might have been not so familiar with RCA, so you learn something about RCA on a very quick base. We have the release notes, the documentation plan, which lists every document, and then the terms and abstract consents in document number 14, which of course you should not read all of them before, but maybe put aside, and whenever you have a question for an acronym or a term, then you can consult that. Then we have that group of documents for the methods, and this is, as I said, related to the next presentation by Oliver later on. In document 16, we start with a so-called ARCH, like architecture process, which is a sophisticated process where you can read about the methods and the rules. So for instance, rules for viewpoints. In document 33, you have some process overview. This is a kind of zoom in, and you have an index file. So it's web-based with a link to every let's say every single process step, if you like. So it's quite thorough information, complex information, so you can learn everything you want to. In document 82, we have the definition of the system release of RCA, the boundary, the actors, the system functions, the capabilities. But there is a small warning. This is currently only valid for a selected subset of these, because we somehow had to restrict. So for the area of the architecture and the interfaces, there is this famous architecture poster, which you have seen already. So this gives you a key insight into subsystems and the interfaces. For the interfaces, you have two selected interfaces, which are the SCIOP from the planning system to PE, and SCI CND from PE, plan execution, to APS. And also you have already a glimpse into the interface which is used by MAP, the SMI interface, which is more general, standing for standard maintenance interface, but in that case is talking a lot about MAP related information. Then we have a, let's say, functional cluster of subsystems, and you see here 3 colors, and you will see these colors again in the next slides. We have an aggregate which we call APM, A for APS, M for MAP, and P for PE. And we have a systematic derivation first of the APM business strategy and the targets, where then objectives are derived from. And then you have for each of the areas or of the subsystems dedicated documents. You have concepts for APS, concept for the plan execution, and concept for the digital map. Now, looking into these areas, so you find again this green color. We start with an APS concept, which is the same like on the last page. Then there is, let's say, a helper document, which gives you an overview on these documents, also provides you with some information how to read, for instance, as a graphical style guide. And then you have an important concept, number 61, which tells about the operating state and the domain objects in the area of APS, which are, by the way, not only used by APS, but mainly by APS. You have then here a part 62 where it is about root setting and root protection, which is, let's say, the first phase, that all the elements are set to the right position. This normally should have contained also a level crossing section. However, we found that from the type of document, it's not yet a concept paper, but more a position paper. So therefore, there's a separate document 79 on principal considerations on level crossings. Then you have a concept about the movement permission, which is important as a second step for the request from PE to APS. So now please, now that all the field elements are set, care for the correct movement permission. And then in this context, we have an important concept, which is the movable object, which is an own taxonomy, not only consisting of track-bound movable objects, or you could say trains, but also of non-track-bound movable objects, like, for instance, in later steps, even persons. Related to that, we have this paper by the LWG, which we made in cooperation with them, which details about track occupancy. For plan execution, we have that already mentioned general concept, and below that you would read, if you're interested in this area, the architectural design, which is about requesting operational plans, the calculation of the movement permission, and the automatic or manual plan execution. If you are more interested in topology, then you have really a big bunch of documents to choose from. So we suggest again to start from the concept of digital map. And if you want to learn about, let's say, economical considerations like cost for data preparation and benefits, then 55 is your document. The document number 54 is a kind of entry point for other documents like 56. Where there are some interesting considerations about how to get the map on board, because it's not only having the map on the trackside, but also on board, especially if you consider ATO levels like GOA 4. 59 again focuses on the air gap between trackside and onboard, the boundaries and the interfaces. Also, first considerations about safety are done here in the preliminary hazard analysis. A very technically detailed document is the map object catalog, where you can find nearly all of the entities we are working on with their attributes. So it's for technicians, it's interesting to understand that and to consult this document, which is derived from document number 57. Which elucidates on the general considerations like spot locations, linear locations, area locations, aggregation levels, and things like that. And finally, you have the document 77 for the quality framework, which is dealing with quality as a needed prerequisite for highly available systems. It has aspects like life cycles or processes. If you are more interested in ATO, and I say more interested because this is already a high number of documents, and I'm sure not everybody will need to read every document. So this is your area now here. You have a general concept of ATO about the purposes, the principles, and the data. And you have then the concept of ATO execution, which gives you the information also on the interfaces, the functions, the business goals, and the derived requirements. For the incident prevention management, so far we have only one paper, which is also a position paper. And incident prevention management is there if you have ATO levels above GOA 2, where you need to react instead of the driver to incidents immediately on the track. And the onboard has to react. So all these things are described here. Now we are approaching again a generic part. You have these documents for the safe computing platform. You might know that in the past there were 2 white papers which were published for a safe SIL4 cloud computing platform. And here you can find this information. First, you have the white paper, which gives the motivation, the high-level objectives, the API design considerations, about arguments about the communication approach, and also the ITsec considerations and certification and authorization aspects. Number 20, as the name tells, is listing a number of requirements, and most concretely, it is in the API document number 30, where the API between the platform and the application is specified, including an application example for those who want to know it very exact. So finally, I think I have even managed to do this in my time slot. I know that this was rather a rush maybe through all the list of documents, but the main goal was to relate you in your interest to the architecture, to the different areas where you can see what areas is most interesting for you. So you could then choose the set of documents to read. And of course, if you want to read all the other documents, you're welcome. So this is really our heritage or legacy, let's say, to present to you of the work of the last years. So thank you very much for your attention.
Thank you very much, Frank. At least we can see that there are numerous documents over there. But we should not be too surprised about that, because in the end, it's almost 5 years that we have been working on RCA. And therefore, being with so many people and so many well-qualified experts, it's not strange that we have a lot of information. But only the number of documents already indicates that it is not so easy to consume everything at the same time. So that's fine. And I think that now that we know what has been produced, even though people can still read it, 50 or so many documents, the question is, how was it produced? And I think the main element, you already indicated it, Frank, is that we used the model-based system engineering as really the foundation for the development of the specifications. And this is for some of us maybe a very well-known topic, but for others it is maybe also relatively new. So it's great that Oliver, that you're going to give an explanation about it, and you can even take a little bit more time if you want to. So please feel free to introduce to us the ideas of multi-based system engineering and explain how this was used in our RCA initiative.
Thank you. I'm glad to do so. As you know me, Michel, I could talk about this topic for a whole day. So 15 minutes is rather a limitation for me. But no worries, I tailored it so it should fit into that. Let me just get this window out of the way. Yeah, thank you very much for having time on the Friday afternoon to talk about the rather dry topic of model-based systems engineering. I hope that number of participants won't drop too much during my part. This part has two intentions. The first intention is to walk you a little bit through the methodology we used, and also to walk you through the documents that we generated out of the model-based systems engineering methodology. Just as a disclaimer, not all the documents Frank presented have been generated by the model-based approach. Some of them are still manual written documents, especially the position papers and concept papers. There's a mixture of it. So we applied the methodology I'm going to present only on a subset of RCA. Okay, let's dive right into the topic. I hope you can see my cursor. I can also switch it here to this fancy laser pointer. That's an overview what our model-based approach comprises. So the core element you can see down here, that is the Capella model. It's a database in the Capella tool, and it's basically our central definition of truth. So that's where we hold the truth, basically. However, if you want to put information into that, you have to do it in a certain way. And that is why we defined something which we call the ARCH framework. The ARCH framework is a process, but also methodology to feed information in a structured way into the Capella model. And it's based on the Arcadia methodology, and Capella is the tool to work with the Arcadia methodology, but like with any other methodology, Arcadia is quite broad in scope. So you can design a lot of different things with Arcadia, and the ARCH process basically refines this methodology into our domain so that we can successfully model a railway system with it. It's quite detailed, as you will see in the reference documents 33 and 60. So it goes down to a process framework where you really have single process steps where you can say, okay, you have to do this particular step. So that's how the information is getting in. I will deep dive onto this topic in my next slide. So please be patient on that. Then we have another building block because we worked in an iterative way. So we didn't do the model all at once with all the features, but we did iterations, and in each iteration we added additional features. And to define which features, which functionality is already in the model and which features are not yet in the model, we use a feature model which is held in a product called Pure Variance. This is also important because, as I said at the beginning, the deliverable for the RCA baseline 1 does not contain everything in the model. So the model only captures a subset. And this subset is also defined by these features and subsequently put into document 80, where you can see which features are in the baseline 1 and which features are not yet in the baseline 1, which have to be then developed, for example, in the system pillar. There's also a technical dependency. You can connect these two tools. The gray arrow here indicates that we didn't do it yet. That's pretty complex to achieve. But if you would do it in the end, you could select features and you can filter the model for relevant features so you can look at what features are changing the model in which way. So a model, that's fine, that's nice, great. We have a super model, but the problem is how to get the information out of the model, because a model is only so accessible and you need some expertise knowledge to access the model. So that's not easy. So what we did, we set up a pretty sophisticated documentation generation engine, which allows you basically to define a document, and that's symbolized here by this area, where you can define your document structure like chapters and introductory text and static text for guiding the reader. But whenever you want to output something from the model, for example, a list of system functions, you can query the model in a specific language. That's not the real language, just some pseudocode I wrote in here. But what happens then is that the actual content of the model is put into this document at the right place in the right format, and that allows you to build basically every type of document by using any kind of information that is inside the model. So that's pretty flexible and a cool way to generate consistent documents. Also, some of the concept documents in the document stack Frank just showed to you are produced in that way. Okay, as promised, let's deep dive into the Arch process, because that's the foundation how we worked in RCA, at least for the RR cluster and at least for the model-based elements we already have in the RCA. The Arcadia method basically defines 4 layers of work you have to do, and we did not do all of them. And something was due to time, for example, the lowest layer here, I will come to that in a second, but something was also intentionally left out, and that's the operational analysis. So the operational analysis usually is a system agnostic description of operational processes, but we left that out due to, let's say, effort reasons, and said, no, we don't do this in RCA. What we do instead is start on the system layer, where we define the system boundary, and then each IM has to check if the system as described here fulfills the own operational needs of this particular IM. However, in the system pillar, there's a task to do this operational analysis, and it's, from my end, highly recommended to do so, because you can do a lot of things already on the operational layer. And so I'm pretty happy that the system pillar decided to do this. It's really important. Okay, so what did we focus on in RCA? We focused on the system analysis and the logical architecture. We did not completely did the subsystem architecture formally. So Davinda already told you that we have the poster, which shows a candidate architecture, but we didn't go into a formal detail in deriving this architecture from the upper layers completely according to the Arch process. That also has to be done, for example, in follow-up projects. Okay, so we followed on the green bit and on the blue bit here, and they have a distinct purpose inside the Arcadia methodology. So the green layer, which is called system analysis, defines what the system as a whole, as a big black box shall do, and what services does it provide to the users. So you can say, okay, we have this system, it has a boundary around the system, it has actors which are elements with the system interact, and we offer a number of capabilities to the user of the system. The scope here for this analysis is trackside and onboard. And that sometimes seems a little bit puzzling. Why is an IM initiative like RCA puzzling with the train side? But the problem is to thoroughly derive the needs. You cannot split the system so early, because especially when you look at higher GOA levels and modern technologies, the train and the track start to become one technical thing, right? I mean, they are by law, they are separated between trackside and trains and IMs and RUs, but they need to interact, and they will in the future interact much more as they do today. So we decided to do the analysis part on the entire scope that was agreed with Okora, for example, and only do the architecture split up. So the architecture for RCA is only covering the track side. The architecture from Okora, for example, is only doing the onboard side, but the analysis was combined. Okay, now we have established what do we need. Okay, we need a system that provides capabilities, but how do we do this, right? There are different solutions to it. The next step is the logical architecture. And some people confuse logical architecture already with, there are subsystems. They have these interfaces, and there is subset 26, and there's some other subset. That is not true in our approach. On logical architecture, the system still is the black box, but we decompose the rather big system functions from the system analysis in individual small process steps. And I will show you that in a second, how that really looks like. Still no allocation to subsystems, still no allocation to track or train side, but just usage of pure logical concepts. And logical concepts for us, for example, are the abstraction of field elements into what we call a drive protection section, or how a movable object is represented on the topology. A movable object could be a train unit, for example. And these logical concepts play into this logical architecture. And then what should have been done, but we didn't do time-wise, was to provide a real subsystem architecture. And this real subsystem architecture then is a technical solution that fulfills the logical architecture. And you can think of many subsystem architectures, but the RCA subsystem architecture would be the RCA answer to this logical architecture. Okay, I think it's important to state that these two layers have done the first time really systematically by a group of IMs together, right? And we know all of the birthing problems of some systems of the past, and I think it's partially to attribute that this has never been done systematically in the beginning, because if you put 5 engineers in a room, they immediately start to talk about subsystem architectures and interfaces and buses and protocols and whatever, but usually very seldomly about what is my need? Why do I need this architecture? And we try to address this by focusing on these two layers. Okay, enough theory. Let's have a look through the documents quickly, and I'm happy that I have a little bit more time. Let's start with the system needs analysis. That's the document for the green bit you just saw. And as I already said, it starts with the definition of the subsystem, the system RCA. So basically what we have here, I zoom in a little bit, is the definition of the black box, or it's a blue box in that case, and a list of all the actors which are around the system and which interface they are connected to the system RCA. In this document, you find then a list of these actors. It's a table like this, where we describe certain attributes of these actors, so you have an understanding what actor is that. Which brings us to the next important section in the document, which is the specification of interfaces. So for each interface you just saw there around the system, we have a section like this here, where we show, I zoom in a bit, the system RCA, which system functions are defined in RCA, and which of these system functions interact over this interface here in the middle with the particular actor. One important thing is that we can already state if there are limitations to the design. So for example, we say the interface between the system and the train driver should be done according to the existing DMI standard. Then we indicate it here by a statement, so that we know for the further levels down, we are limited to this scope. We cannot invent something new. We should do it like this. For a lot of interfaces, we don't have a limitation. Then we can design whatever we like. So that's important, because the green box, the system analysis, also states the limitations where we are not going beyond, right? So the next important section here is, I zoom out a little bit, is the definition of the system capabilities in terms of services. So you have a system capability, for example, here, provide navigation data of one train unit. That's where is my train and what it's doing, right? And we have the list of the actors that are relevant to the system capability, also which other system capabilities depend on the system capability. And then we have, again, a table describing things like the pre and post conditions, but that's not what I want to focus on. I want to focus on how we express it in terms of system functions. So for each system capability, we have one or more of these diagrams that show how are my system functions used, in which order or in which parallelism are they used to fulfill the goal of the system capability. And you see that the system functions are rather big. So for detecting the position of a train, we just say something has to sense the motion, like a sensor, like I don't know, an axle counter maybe, or a balise, or a wheel rotation sensor or something like that. And then there's some mechanism inside the system that needs to put all this information together and say, okay, your train is there and it produces an output. So we have inputs in blue and we have outputs in blue, and in between we have the system functions. These system functions really are huge. Speaking of system functions, we have then a list of system functions. That what I showed in the mock-up of the document. So the list of system functions, and this list is usually has a diagram like this. So in the middle there is the function we are currently looking at. We state which inputs are required for the system function, and with output is the system function producing. And then we have a description of the function as well. It's not a specification, it's just a description. We are not in Senelec compliant documents at the moment. And we also have a rationale. Why do we think this particular function needs this input to work? And this is only stating, again, the development need. It's not a solution. We don't say how controlling the position of one point in this example is working. We just say this is something we have to do, and we assume we need these inputs and produce this output. Everything else needs to be done in the lower levels of specification. Showing this, we have to go to the other document. And this is document 81. That's the logical decomposition. And I jump back in this document to here, where we had the system capability located train unit. And as I just said a few seconds ago, we have these outputs, we have these inputs, we have some system functions, and we have this output, right? And it's the same here in this document. That is exactly the same system capability. 3 inputs on this side, 1 output on this side, and some additional information. But here we see that we have much more functions. I can zoom in a little bit. And this is because we split up the big system functions in much smaller logical functions, each representing one distinct processing step in the chain from input to output. And these smaller functions are then allocatable to the real subsystem architecture, which comes in the next step, right? The next step, you can take these functions and allocate them to different building blocks, and you can evaluate different architectures. So you can say, maybe an architecture with just 2 huge systems, and we allocate a number of functions to these systems would be the right way. Or you could say maybe an architecture with a lot of systems and each just gets 1 function could be better. And for RCA, we didn't do this, as I said, formally, but we have, of course, thought about the architecture according to principles. And the RCA poster basically is the outcome of that. So that's the candidate architecture we need to allocate these functions to. Okay, so much for the documents. They are pretty long. You find information on any functions, any system capabilities in there. Just go through them. Now back to my slide deck. Just a short pointer, then I'm done, and I'm just 1 minute beyond schedule. That's pretty good. So we have a limited scope of what is already modeled according to this methodology. You should read RCA Doc 5 because there's a pretty good explanation what is in and what is out. That's just an overview. I think we also provide this slide deck for download later, so you can have a quick reference. But if you want to look into RCA Doc 5, and there's a pretty good explanation what is already contained and what has already been modeled according to this process. So I don't have a nice end slide, but I hope this was not too much information for a Friday afternoon. And if I find my Teams window, I will stop the presentation and hand back over to Michel. Thank you very much.
Thank you very much, Oliver. I'm not sure about the others. They are all very silent, but maybe that's because we have shut down their microphones. But I must say that I was really, for me, it was a very interesting lecture. So I really appreciated it. But as you know, I'm a novice in MBSE, so probably I have to read a lot more and to learn a lot more. This is, of course, not to say about Roman, because Roman is, I guess, one of the people who has been working a lot with that. So Oliver, thank you very much for explaining about MBSE. How did we come to, let me say, really the content of the reference CCS architecture, which is documented in all those things which have been explained by Frank, and achieving the big picture drawn by Davinder. So that is basically what we have, and we have combined that in baseline 1.0, I should say. The question is, of course, what are we going to do with that? What's next? And that is where Roman will tell us a little bit more. Of course, some of you have already indicated, or some of the previous speakers have already indicated it a little bit. It's called System Pillar. But Roman, you go a little bit more in the details over there. The floor is yours.
Yes, thank you, Michel. So I will share my screen. Yeah, as Michel said, I will talk about transition to Europe's rail system pillar. So basic question is, how are we going to continue our work? Where will all the future work on those content take place? Yes, I'm starting with the short explanation of what is Europe's rail, what is the background. Legally, it is founded by a single basic act, so it's an EU directive, which was published in November 2021. And is also the legal successor of Shift to Rail, which is interesting because it inherits all the results from Shift to Rail. In this scope, especially interesting, I would say the work of the moving block work package, which was done in Shift to Rail. And I think a lot of this can be combined also with the work that has been done in RCA to form one standard in the end. It is legally a public-private partnership, so many infrastructure managers, railways, and also supply companies are partners in this program. And the aim is that railways and suppliers work together here to form current and common standards. So the main goals of this Europe's Rail program are to improve the overall railway system, which means having in the end a higher modal share of the railway in the transport, having all the public transport in medium range carbon neutral, and then you see the kind of political numbers like doubling high-speed traffic or tripling even by 2050, a lot of more freight traffic on the railway, and quite important, of course, for all the railways having a fully operational TEN-T network, so that all cross-border traffic could run seamlessly and have in the end more competitiveness of the railway. All of this should lead us to a single European railway area in the end. So this is the whole goal, coming from the quite fragmented railway area, even so we have some standards like ETCS that allow cross-border traffic. Lots of especially operational processes and procedures are still quite national, and it's not so easy to run a train from one country in the south of Europe to the north of Europe or something else. So this is where we want to go, one single European railway area. To achieve this, the system pillar is set up with two, the Europe's Rail is set up with two big pillars. The first one is the system pillar. And here you find work on operational concept, on a system architecture, requirements and interfaces, and a system pillar is responsible for creating standardization output that can then become input for TSI publication. So for example, produce enhancements for the CCS TSI. Then on the other side, we find the innovation pillar, and there you have all the research and development activities and the more detailed work. So the system pillar will be more working on the architecture and keeping everything together, operations and so on. But kind of detailed development on some specific things is done in the innovation pillar. And of course, in the innovation pillar, we will see demonstrators that will showcase specific technologies, specific developments, and then practically demonstrate where we want to go. And it's organized in those different flagship areas like for ATO, regional, and so on. Those two pillars are of course also linked. So the idea is that a system pillar can provide architecture and also the operations to the innovation pillar so that it can be used in the innovation pillar projects. There should be some exchange on the lower level of specifications, so coming hopefully together to interface and requirements work together in those fields. And in the end, the system pillar, could profit from new developments coming from the innovation pillar. So if we find out in the innovation pillar that, for example, some new technology is now mature enough that it can be integrated in a standard, that could come then from the innovation pillar to the system pillar. So this is kind of the formal way how this could work together. Of course, many companies are anyway involved in both pillars, like DB, for example. So we have a high interest that both are linked and that we are working in the same direction here for both the pillars. Then very important for me, the most important thing in the system pillar is this end, what I highlighted here in the headline, that the system pillar is aiming at standardizing both operations and architecture, because in the past, also in Shift to Rail and other programs or ETCS, we really only looked at architecture and at interfaces, requirements, and so on. But all the operations, or most of the operations, is still quite national. And this is, for me, one of the main reasons that we have such a diverse landscape. And what Steffen showed in the beginning, that we have not a harmonized market, for example, that you cannot easily apply a product from country A in country B and so on. And so this is one of the big goal of the system pillar, that we have a harmonized operational process and a harmonized architecture and requirements for CCS and TMS in the European countries. And then the second aspect here is also that we have to look at migration, how coming from national systems to the target system. So the system pillar will work on a target system primarily, but there is also a work package dealing with migration. Of course, we cannot define every migration step for every country in the system pillar. That's also not responsibility of system pillar, but I think there can be some generic migration considerations, highlighting steps that you can take, different plateaus that can be reached in between before coming to a joint standard system. And in the end, I'd like to highlight that in ramp-up phase that took part until summer this year, we were already able to form a big part of the system pillar on a high level. And in this ramp-up phase, there was also importing of previous results, both from Shift to Rail, but here for this presentation, I had that also from RCA, we inputted all the different documents as Frank has shown to the system pillar ramp-up phase. So to ensure that all the work that has been done in RCA is not lost, but can be used as a base to develop a common standard here. When looking at the system pillar, we have quite a big organizational structure. The head of all is the system pillar core group. And then below that here, you have 4 different tasks. Task 1 is dealing with the complete railway system. Task 2 is focusing on CCS, task 3 on TMS, and task 4 on the automatic coupling. The content of RCA you can find in the future mainly in this CCS task here, task 2. And when you zoom in task 2, you see different domains here. Operations, architecture, and migration are kind of more cross-cutting domains. And the RCA content, of course, is placed very much in the architecture domain, but it's also impacting, of course, operations and migration considerations. And then we have specific domains dealing with specific parts of the architecture. Most important here for the RCA scope is the traffic control and supervision domain, where I'm the lead on the railway side. So I will also make sure that we can continue the RCA ideas in this domain and use this as a base. And then we have also domains like transversal components and compute platform, which are also kind of affected by some of the RCA ideas that have been developed and are published. In the system pillar, we can see that in the system pillar report, it's already mentioned that we have some key design principles for developing a target architecture. And one of them is having a traffic management very high automation. and having signaling that is only based on ETCS, radio-based. We want to have localization of all the vehicles using kind of a sensor fusion from different information, like you could have train integrity, you could use axle counters, you could use whatever sensors in the future that might appear. Having ATO or grades of automation, having the safe execution of revving movements based on real-time operation situation. That means basically taking all the information that you have, compiling your current operational situation, and based on that have a determination what movement is safe and what is not safe. Then another design principle is having a modular architecture, and last one, support of the DAC. And when you look at this, I think you can clearly see from all of the tests being presented before that this is quite in line with what also the aim of RCA was. So I think you can find all of those principles also in RCA, except for the DAC. DAC wasn't really in focus for the RCA, but it's of course welcome as a means to establish the train rear end. But we can see that this lives on in the system pillar really. Then this here is taken from the system pillar ramp up. So it shows you the high level architecture. This looks really a bit different to what has been done in RCA, but when you go down one level, you can actually map it. The traffic management was not in the scope of RCA, but it's now in scope of a system builder. That is a clear difference. Then we have this big area of traffic control and supervision, all the track side kind of microscopic optimization, execution system, and of course the safety systems and the control of the ATO track side. This is all this traffic control and supervision on the track side. And then we have here the train control, which is basically ETCS, ATO, and in future automation of the train. We have a field force part here that has also played a role in RCA. You find it in the common architecture view. We haven't done a lot of work of that in RCA. It was not the first priority, but it was always in a way that when we developed systems and then requirements in RCA, we already thought about how in the future this could be connected and integrated. And lastly, you have the trackside assets domain here or part of the architecture, which is basically the U-links. So this is fully compliant with what we have already done in RCA. And then you have here all the transversal topics. So all in all, we can see that it's quite, it can be quite related to what has been done in RCA. Of course, it's not 100% the same, but I think we can do quite a good mapping here. So finally, before ending my presentation, I'd like to give you a short insight in what we have already done in this ramp up project. This methodology, what Oliver has explained earlier, was used in, I would say, a light version to already develop a consolidated view for this traffic CS domain here. We developed kind of external view showing all the actors, showing main system capabilities that have to be fulfilled by this traffic CS system in the end. So like performing a train movement, of course, reacting on incidents, joining trains, splitting trains, and so on. So this is basically our requirements that we have to fulfill in the end. And we also managed to derive from that for each of those capabilities some internal view, not going to explain all of that, but just to show that how we could come from this high-level picture to then concrete interfaces and requirements. We developed this functional structure, which gives you the main functions needed for executing such a system capability, and also showing exchange between actors and between the functional blocks that we see in here. And the next step will then be that you can allocate those functions, or detail them, of course, allocate them to specific systems, and then you would have interfaces between the systems, and those interfaces would be interesting in the end to standardize and to have as the output of a system pillar, which can then be reused in TSI, for example, or for tendering. Yes, and with this, I would like to close my presentation. Thanks a lot for your attention, and then back to Michelle.
Thank you, Roman. I think that your presentation clearly shows that even though we stop with RCA, the story for RCA ends here with the baseline 1 or the release 1.0. The idea is that this is a kind of a legacy, But even though RCA stops, the ideas of RCA are well taken over in the system pillar, because indeed the system pillar, I would also say, to make it a little bit more also clear that we from RCA actually were in the initial trigger together with Ocora, initial trigger for the commission to say we need to have something like a system pillar to do this in a united way. But it is very nice to see that the ideas of RCA, where it all started from 1 hour and 10 minutes ago, explained by Stefan, that this has resulted now in the setting up of this the system pillar in EU Rail, and that we have very good opportunities now to develop this further. And as it was said by a couple of the presenters, the work in RCA has not been complete. We made the first step, so to say, but there is lots of work in addition to do. The details are always a little bit more complicated, and it's great that we can see that there is a future for all these ideas in the system pillar. So thank you very much for that. We have some 50 minutes left for answering questions, and we will very soon open the floor also to you who are now in the webinar. But we will first start with a couple of questions which actually you already raised, or we invited you to put to give a couple of questions what you would have liked us to answer in the webinar. We made a little bit of an analysis on that, on your responses or your questions. And I don't think we will deal with all of them, because then it will take probably so much time that you will not have possibilities anymore over here to have an interaction. But there are some which maybe it would be good to start with that and first do that, and then we continue with the interaction, as I said. And looking at those questions, maybe also to give Stefan again an opportunity to say something, because it's a long time that he shut up, and that's very difficult for Stefan. Stefan, a question is, can you say something, or maybe also the others, but let's start with you. How does RCA affect the current projects which are in planning? Is this a threat? Is it an opportunity? How should we see that?
Yeah. By the way, we have the same discussion also on the system pillar, how to put out early, concrete, usable, tangible results that can be made use of. And to understand how we can do that, and at first I would see it as a chance or as a possibility. All these works, and this will be the same for the coming system pillar, can already be used in terms of supporting, for example, current procurement processes, supporting operational designs into the right direction. So, for example, we have requirement sets, we have general structures, we have new architecture principles that simplify the life cycle. This is at first per se as a concept or as a requirement set, or already as a logical architecture usable in doing current projects. Then, of course, the next step is when people think about threat, well, what is the reality? The reality is when you buy a new phone, the next one will have more features. Well, this is the reality. So what we are working on here is, when you take, for example, the trackside, the interlocking, we're defining a requirement set that has much higher ambitions than we had in the past. And of course, when it is implemented, which will be, of course, done in phases, not perhaps everything at once, but we have much more features and newer features. So the expectation is that we will have better products, and this means in the end, they will be not available now, but in the future somewhere, that we have new chances and new products in the future. And of course, the big thing is now, and this is the biggest discussion also for the migration team in the system pillar, to think in every product and every contract we do about upgradability. What does it mean? What does it mean later on if we want to make use of this newer developments that will come? How can I upgrade to them? And there are technical and operational and also contractual concepts to that we will also show in the system pillar.
Can I say something, Michel?
Yes, go ahead, Davinder.
Yeah, so I think the key thing is, current investments are, they're decided. That nothing can be changed about that. But for future investment decisions, this is an opportunity. And need to think about the cost for resignaling. And what we're trying to achieve here is a greater, not just greater benefits, but also reduction in cost, reduction in resignaling cost, and reduction in whole life costs. So RCA needs to, come across as being attractive to potential future investments. Thank you.
Michelle, I'd also like to add one thing to that. I mean, to help this migration, what Stefan said, you can already invest today in Ulinx standards. So buying your object controllers and fitting them with Ulinx interfaces and connecting them to your proprietary interlocking for new project, that already helps a lot because most of the cost is normally in the field installations. And when you have that, and when you have ETCS on your vehicles, you have basically the two big migration steps that you can do now already. And then you can in the future upgrade your trackside centralized system, but not re-signaling your whole line again, using, for example, all the point machine interfaces and so on, Excel counter interfaces that you already installed, and then just changing out the installed trackside central system.
Okay, Oliver, you also want to add something?
Yeah, very shortly, just because everybody seemed to have something to add at this section. Just saying, yeah, even beyond the physical assets, you can already maybe look at like the object controllers Roman mentioned. Of course, even if RCA hasn't finished the specifications, it's like, here's the spec, go to your supplier and buy it. Of course, the concept papers already show the way in which it is going. So if you happen to work for an IM that has its own development project, as we have at Deutsche Bahn, you can, of course, take RCA as a blueprint and to follow the ideas there. And then it could be that your own projects are more in line with what is coming most probably out of the system pillar when it shapes according to RCA. So there's not only physical things you could already buy or tender, but you can think about the concepts. And that's why we documented a lot of this things in the RCA concept papers to convey all the ideas and thoughts we had.
Okay, thank you. Well, I cannot resist then also to add something from my side. Two things. One is it was mentioned, I think, by Stefan already that the foundation of this is radio-based ETCS. And we have to bear in mind that the specifications for ERTMS talk about, I think, shortly less than 30 years, but they are quite mature. And we know that these will not remain the same. They will develop further, but there is a huge, huge interest for everybody to make sure that we evolve these specifications in such a way that we do not lose the investments. So I think that all these projects which are now, let me say, installing ERTMS should not be too worried about the fact that in the future there will be something called reference architecture or whatever. That is not going to be a threat to these investments. We will make sure, and that is of course also an important element of the migration, we will make sure that the evolution of the specifications, and this is not only about ERTMS, but it is also about EU links, they will make sure that the evolution of these specifications will be completely in line with the development of the target architecture and making sure that the migration will not be hampered. But there's another element which I also would like to add over there. How much of the whole network and the fleet is covered by the existing projects? If you think about that, that is only a very small part. It's an important part, of course, but it's a small part. So if I just, in my innocence, assume that this is 5%, then I would say, let's not look too much on the 5% of the current projects, but let's look at the 95%, which is there, which still needs to be tackled in the future. And that is coming back to what Davinder said. That's where the system pillar is focusing on. So don't be too worried about the existing projects. That would be my recommendation. I think we said enough about this question. Let's go to another one. I'm not 100% sure who to address this, but I will give it a first try with Davinder. How logic is the safety logic?
How logic is the safety logic? So I think, you know, there are several aspects to that. I think the key thing is that, as described in the documentation, in the release documentation, there are some key principles around that safety logic. And so some design work has been taking what's already there in terms of the interlocking principles that have been defined previously, and using a design methodology, but also thinking about how to formalize that, and bringing those concepts in, some new concepts in, for instance, about how an intelligent train is going to supervise release speeds. So there's many aspects to that, and trying our best to understand how we can best validate and verify that. So when you say logic, that's actually probably quite a big word.
Okay, Frank, you want to add to that?
Yes, I think the safety logic of APS is very logic, because it puts into the center the train. So it's a train-centric logic, and it's very logic to do so, because this is our business object. It's now not our business objects that we have occupations and blocks. These are only auxiliary objects somehow. So I could even reverse the question and say, how logic is the current safety logic? It's not very logic, because it's dealing with something else. Now we are putting the train into the center, and this will be a logic step which will help us to do a good safety logic, which is simple and very stable.
Okay, thank you. Can you resist not to respond, Roman?
I think was well said.
Okay, then we go to another question. And again, I'm a bit, let me say, maybe I try this with Oliver, but it could be that in the end, Davinder, you also have to say something about it. How to prevent that more modularization leads to more complexity, less optimization, and higher costs?
Yeah, I can try my bit on that. Of course, when you have more building blocks, then you have more complexity, because you have more interfaces and you have more combinations possible. But the problem is that a lot of the complexity at the moment comes from not optimal specifications, right? You don't have a really hard specified interface specification. It's sometimes written in plain text. You have interpretation there that is possible. And I think my answer would be, of course, in the architectural trade-off, you have to find the sweet spot between only having one big monolithic system, that is what we most of the time in the last 50 years bought from the suppliers, and an architecture where you have 500 subsystems, which also wouldn't be great. But the methodological approach we take allows for exactly types of trade-off between different architectural ideas or different architectural concepts, and then seeing which of the concept seems to be the best. And yeah, indeed, it's a question of finding the sweet spot of modularity, but also not stepping into the complexity trap here. But I think we are well equipped to exactly perform a good analysis on this topic.
Davinder, would you like to add to that, or?
Yes, I think we're trying our best, as I said in my presentation, to make those trade-offs, and we're acutely aware of the constraints. You know, as Stefan says, this is about faster deployment. We don't want to increase complexity, which could increase the time to take to deploy, or increase costs, whole life cycle costs. Yeah, we're acutely aware of that. But what we are also aware of is that, as I said in my presentation, if we could minimize, for instance, the number of physical interfaces, if we could minimize the safety validation and verification by virtualizing the functionality using this safe computing environment, right, then we're abstracting and isolating change. So we know the system needs to change. The railways are not very good at change. They're terrible at change, but we need to change. We know we have to continue to change. We know we have to evolve. But if we can isolate that change, and it doesn't impact the safety logic, so we don't have to revalidate the safety case, then we have a chance of reducing cost. So we know the scenarios We know how we think we can reduce cost.
Perhaps if I may also add something, Michel, just a short one, coming from the business case, a very simple picture. Also, of course, same discussion in system pillar. When you think of reusing things, which is nothing else than standardization. So agreeing with people afterwards, everybody can reuse it. It means you don't do it anymore for yourself, and this simplifies your life. So standardization is per se not more complexity, but of course, aligning with everybody is more complexity because you have to agree on things. But just consider for every procurement document, for everything you do, except of course it is part of a competitions area, there we will have our competition situation as before, but for everything else inside of railways or suppliers where reusability is the big business case, it makes your life simpler. So the important point is just to find the right balance. Where is the reusability argument really the good one? And where is the, for example, in terms of competition, innovation, or other elements, where is the individual approach the better one? And this will be a case-by-case decision per interface. It is not a generic, and there's no generic answer possible for everything, I think.
Yeah, well, guys, you have to be careful. If more than one takes the floor, then I have an intention also to say something to this. And so I cannot resist adding to this. I think you mentioned earlier, Stefan, that we talked about this also with suppliers already 2-3 years ago about, okay, just how far should we go with granularity? And maybe coming back to also what Oliver said, 2 times, by the way, but the first element is by making it so explicit and etc. Then you can also identify clearly on where should you make the separations, etc. And we don't have to start with everything at the same time, as we said. So the sweet spot, as you called it, Oliver, that will probably also be a moving target. I think if we start in the system pillar by looking first at larger boundaries of the system, but we know that we have a very logical structure internally in that, and we know that, then we can also go in a later step towards a further granularity of the system. So we do not have to go upfront to a very detailed split up of all the subsystems. We can also do that later on. Just as long as we do the right things and we do not create the wrong ones. And for that, the analysis which you have explained, Oliver, is of course a very important first step in that. So the fact that we go to such a level of detail in the functional and logical architecture is not to say that this by definition will then already result also in so many different subsystems. It might well be that we first concentrate on much more integrated systems, but with the possibility to split it up later on a little bit further.
It's a reference architecture.
Indeed. Okay, then maybe just one final one before we give the floor. There were really a lot of questions, and maybe not strange about that, which are the concerns about migration. Now, this was already touched a little bit by you, Roman, in your presentation. So maybe we have covered it already, but is there anything in addition to say about migration? Because this is really the big issue for a lot of people. Can we even get out of our existing systems towards such a wonderful new target architecture? And maybe it's also for you, Davinder, I don't know, but maybe Roman, you can start.
Yes, yeah. In addition to what I already said in my presentation, or mentioning the U-Links and ETCS equipment, that would be, of course, a big migration help to do this already. I think from railway perspective, the biggest migration issue is to migrate operational processes and requirements and planning rules and so on, because normally railways have a lot of those things, and this is still quite national, and often philosophy and everything behind that, the whole railway system is built for that. So when we look at going to a common target system, this is from railway point of view, I think the biggest migration issue. And I think in the overall process might be even more complicated than having a product migration from the supplier side, because I think products are more or less going in the direction of the target of the system pillar anyway. You know, or when we look at things like urban rail, where they have those integrated systems already part of. So yeah, this is what I would like to add, and maybe somebody else also wants to say something.
Yeah, I think there's many different aspects to that, and we'll try to summarize what I think. So the first thing is the business change, and going from physical machines that sit near the track side to a software-based system that sits in a computing data center, which is geographically irrelevant. So signaling engineers will become data engineers, and trying to understand that concept, I think, is massive. In terms of the aspects of signaling, then it's when the resignaling opportunity occurs, how does that fit with that environment that you're trying to resignal? You may have conventional signaling, you may already have ETCS there. So it's being able to deal with that environment, which and continue to support, as you said, Michelle, ETCS level 2 or whatever the TSI is saying, and that functionality, and RCA supports that, but being able to interface with conventional signaling in another area of control, or sidings and fringes, which may not be ETCS enabled. So it's understanding all of that. And then finally, and I think this is one of the biggest areas, is the degraded and emergency situations, and understanding how the system will behave when you have those scenarios that you are entering into Donald Rumsfeld's territory of known unknowns, and worst of all, unknown unknowns. So it's understanding all of that, I think, and we don't know necessarily the answer to all of that, and this will happen as RCA matures.
Okay, thank you. I think both you and Roman, you touched also this topic about the operations, the degraded modes, and the fact that in all countries this is different. My observation is also that from operational perspective, a lot of the operational procedures, etc., are, let me say, a result of incidents which have occurred in the past, and every country has its own incidents. So therefore, that is also, I think, one reason why things are deviating. But most of the time, this is also, these incidents have, of course, also caused the fact that you have different safety laws in all the countries, and changing a law is not an easy thing. And that could really be kind of, well, at least a barrier to say for coming to harmonization of operations. Is there any view on that, on how we can solve that issue?
So you're talking about harmonized operational processes?
No, what I mean is, if you're going into discussion about operational concept, degraded modes, etc., you most probably will run in the fact that you will have discussions that safety laws do not prevent or do prevent some solutions in one country which are good solutions in other countries. So we need also to have a kind of a bringing together of the safety laws in Europe. That is basically my message. I wanted to have it out of your mouth, but now that I have said it, I think it is already done. So that I think one of the important things in the system pillar is, and that should be done under the direction of the European Commission and the railway, the agency for the railways, is to make sure that we also come to a harmonization of the safety laws. We have to ask ourselves the question, why is something safe in one country and not in another country? And tackle those things, because otherwise we will end up with terribly complex situations. Oliver,
Exactly.
you want to add something to this one as well?
Yeah, very shortly. That is why I said that the operational analysis is so important, and we didn't do it in RCA, but we should in any case do it in the system pillar, because to harmonize these European safety legislation, or whatever you want to call it, it would be interesting to first align on how we think that railway operations should be done in the European Union. And we have never had a chance in the history to do it like we can do it now, because when we look to the future, the reduction of different signaling system, the reduction of special technical solutions that have come out of the history in every country is now at our doorstep, because with ETCS, Not everything went well with ETCS, but we have a technology that is in theory agnostic of where it operates. And if we also in the future think about highly automated operation, I know a lot of people don't believe that GOA4 will be a thing, but let's talk in 20 years. Then we have more human interaction out of the equation because the system does more automatically. And why do we have so many different operating rules and different assessment what safe is? It's because we always had different histories of how humans interact with the system. If you don't have a train driver, we don't need to teach them different signaling rules. We don't have the risks of something going wrong. So I think the opportunity for aligning on a common European operation and therefore also on safety rules and safety assessment has never been as good as it is at the moment, and we definitely should go for it in the system pillar.
I see that you do not have to be convinced for that, Oliver.
No.
Thank you very much. I think it is now time to open the floor also for reactions from our members or our participants. Stefan, have you opened?
You're muted, Stefan.
Yeah, the chat is open. I already see a lot of questions. I answered some of the simpler questions already in the chat, but let's go through it. So we have one question. I'll start at the top. So there's one question: could RCA be used to replace current ETCS level 2 infrastructure implementations? Wants to answer, or shall I give it the try to answer it directly? So yes, of course, RCA is a design concept. The system pillar will put it down to new specifications, see it as a, let's say, on the one hand, very precise operational specification for operational rules. On the other hand, a list of interfaces, standard interface specifications that will come out step by step. And this will start next year, not in 10 years. So for example, for the trackside assets, and then in 2 years, there will come some other stuff. And of course, every time a specification comes out afterwards, development processes start on the market. This will take a while. And let's say some years later, these standard interfaces will be available in the products. As far as the development is mandatory. Sometimes it will just be a guideline. So it will be available in the next years. So it is, of course, a decision of the asset owner and the investor when he has a level 2 implementation just installed and it's, let's say, 10 years old. You know that as an asset owner, he will decide, well, does it make sense for me to make use of these new features and business case elements or performance elements, or simply asset management advantages, for example, by centralization? Or do I wait until the asset or the installation is end of life, and for that time I just use the installation that I have? Because what we introduce is just a very cost efficient and performant solution for something that we already do. Today we have level 2 installations. Of course, the newer systems will support in a simpler way a hybrid level 3 or other configurations, but in general there is not, in terms of interoperability, there is no legal constraint that pushes us to the point that everything has to be replaced or something like that. So it will be a business case decision from the asset owner when he wants to improve his radio-based ERTMS installations with a newer product that we will have in some years, if he wants to do that.
Thank you. I've meanwhile also looked a little bit in the chat. I do not see any hands raised. If you raise your hand, of course, we will also pay attention to that. But looking at the chat, one of the question which was supported a lot of times is, and maybe it's a logical, it's always the same question, are the slides and or the recordings available? I think it was answered already, but maybe we can repeat it again. I think, Roman, you said it, and that they will become, and I would imagine that they will also become available if you go to this ertms.be site.
Yes.
And
yes,
that we will make sure that. So all you need to know is ertms.be, click on it, and then you will quite easily come to the domain of RCA, and you will also find the slides and the recording which we have. Of course, it takes some time before we have the recording over there, but in a couple of days or maybe even a couple of hours, you should be able to find them. Then another question or something which also got a lot of things. that is maybe this one is even nicer. How much is all of this aligned with the industry? Maybe that is again, I think, an interesting question. Maybe Stefan, can you say again something about it, because you already started it? But maybe you can explain it a little bit more.
Yeah. So what we have is a joint white paper, and signed it in 2020 together with the UNIFE steering committee, that we have the same perception about the problem statement. So it is clear that there is a need to go on this. It is very clear for, I think, the full sector. You can see that when you also read the system pillar report or the agreement in the system pillar or in the ERA, you can see that everybody sees the need. We have to change the way we are working on it. Also in the last steering group, for example, some weeks ago, everybody was clear again, we have to change the way we go on. And it's not only standardization, it's of course also the quantum leap of the system. We have to change the business case of the CCS system. This is clear. And then of course we go down step by step. So when we go to the next level, which are the requirements in detail or the business objectives, that we still see, for example, the common business objectives, the 80 that are on the top of the system pillar, are agreed in the steering group, also by the industry. Again, I would say same perception. But then, of course, when we go down to the details, there are not everything is clarified. We saw that in the ramp-up process, there was a lot of alignment between the groups in the ramp-up process, but also, of course, differences. I mean, this is quite normal in the engineering process, that at some, for example, interfaces, there are different perceptions how to solve it. And this is not, let's say, a blocker or something. It is just work to be done, because we need more assessment and we need more evaluation for some of the interfaces. But the good thing now in the system pillar is that we do everything together. We have in the core group, we a joint team, industry and railways. We are in the domain now, a joint team completely. And we have a clear governance process to take decision faster in a good way. So it will now improve, or the speed of alignment will now improve.
Yeah, thank you. Maybe I can also add something to that. So I would say to the question, how much is this aligned with the industry? It is fully aligned with the industry. That is not to say that the suppliers are fully agreeing with everything which has been developed in RCA, of course. But indeed, they are well aware of it. We have spent a ramping up process for that, and there's a lot of understanding for what has been done. And I think acceptance is a high word, but I think there is a lot of positive attitude from the supplier side on, okay, that makes a lot of sense. Let's continue in this way. And also to repeat what you said, Stefan, I think we made a big mistake in ERTMS in the past. Because Railway thought that they were the ones who should say how ERTMS should be built. It took about 10 years before the suppliers actually were put in the position that they could demonstrate that also they are not able to do that. And I think the last 15 years in ERTMS, or the last 10 years, no, well, 15 years, yes, you can say that we have quite a good way of working together with the suppliers on developing the specification, recognizing that railways know a lot about the needs, the functional needs, etc., and that of course the suppliers know a lot about how to build systems, and respecting that, we can do a lot of things. For the system pillar, it was clear, and the supplier said, we don't want to work on anything from Ocora and RCA unless we can do this in an EU-funded project. And in the end, this became EU Rail, the successor of Shifter Rail. But we have also agreed that we will do that in a balanced way. So there is no dominance of the suppliers. There's also no dominance of the railways. We have to do this together. And the way we have tried this out in the ramping up of the system pillar, at least gives me a lot of confidence that we really can go ahead with this and achieve success in a successful way, results. So maybe adding that a little bit to this question, because I think behind such a question is, of course, the industry will not agree with it. Well, I think they do. And they also recognize that there is for them a lot of opportunity, like Stefan already explained. Okay, then maybe one other question which also was really put out there, or it was more a statement. It reads a lot of theory. What are concretely implemented projects in the context of RCA yet. So maybe this was already partly addressed by some of you. I heard Roman saying something like there is already EU links available. That you can see this as a part of RCA. And of course ERTMS is there. But maybe there is something more to say about that.
Yeah, I can say it a bit from the DB perspective or experience. We have a technology development plan for the coming years. And of course, the current goal is to get everything involved in digital interlockings in level 2 ETCS without line-side signals on the way, which is kind of almost there. And there are big projects on the horizon that will implement this. But when you look back 10 years, there was more or less the same situation. Yeah, people started, or even before, working on the project that became U-Links inside DB and trying to standardize those interfaces and so on, thinking about ETCS and so on. So all of that took quite some time. And I think we are now in a kind of similar situation. Yeah, now we have the first wave of digitalization with ETCS level 2 and the U-Links interfaces, which are more or less becoming the standard, which is implemented everywhere. So normally everybody builds level 2 nowadays when you build new signaling. And what we have here proposed with RCA is basically the next step afterwards, and this is also integrated for DB in the planning. Clearly, we know that it takes some more years to develop all of that. Yeah, as Stefan explained, maybe some of the results will become available earlier on, but it's quite clear that we need some time. We need some time to specify and so on, to agree on standards, to prototype things, to have pilot projects running and so on. But that is quite normal for this technology. So you cannot expect that you do just like this and then it's implemented. So yeah, this is how it goes. It's in the roadmap, in the planning, and we are quite sure that this is the future and that we have to work on this.
Can I say something, Michelle?
Go ahead, Devender.
Just a couple of things. I think the first thing, similarly in Network Rail, in the UK, we have a long-term deployment plan, which is all about reducing cost, life cycle cost for resignaling schemes. And RCA is part of our target architecture and part of that plan to reduce that signaling cost. And is what we see as a key enabler to allow us to address the signaling challenge we have on the GB railway. So that's the first thing. I think the second point I wanted to make is the first part of that question, a lot of theory. Well, we know it's already been done with CBTC, and other industries like the airline industry have managed to do this. So we know it can be done. It's just mainline railways and being able to get away from these physical machines into a completely different environment is one of our biggest challenges. And yes, there's still a lot to be done. It's not necessarily the technology, but it's the business change, having the capability in the railway industry to allow this to happen.
Okay, thank you. Then I think we've got a question over here, which maybe Frank, you can say something about it, and maybe also Stefan. How are the RCA docs going to be used for the system pillar? As one of many input documents, so for every topic new documents will be created, or as the primary starting point for the development of the system pillar?
Yeah, I can say something about it. Of course, since RCA was a railway side initiative, of course, we cannot just use it and start it directly. So it needs an assessment process together with the suppliers in a joint team and then the new system pillar governance, of course. But on the other hand, and I think it was seen already in the ramp-up process, it is a very cooperative situation. So we are not trying to invent something new that is already there. So it is clearly said in the system pillar report that we will make use of all sector initiatives coming from Shift Rail to Okora to U-Links to RCA as much as possible. Of course, together with this, let's call it import process, so joint assessment, and perhaps we have to tweak some elements, optimize some elements, or put more opinions in it. Of course, this agreement process and alignment process is necessary, but there's no plan to invent everything from scratch. Of course not, because when you see the roadmap definition of the system pillar, we have now, as you perhaps know, we have 250 domain people working on it and some hundreds of mirror group people. We have a lot of power now to get up in speed, and it is a new type of organization, which is more like an engineering company. And this organization shall put out results really in the next 3-4 years that can be used for product development and for demonstrators earlier. So there's pressure on it, what I want to say. And so there's no idea from starting at Adam and Eve again. So not at all.
Frank, would you like to react on it?
Yeah, I'd like to add as well. Ollie, if you first.
Well, I would first like to give the floor to Frank, because unless you don't want to add something, Frank, but
Well, I think for these documents which we have as an input, they have already been considered in the pre-project phase of the system pillar, where Roman can better talk about that. And we also want to bring in our documents in the later phases. And we know that there are also documents like Shift to Rail, which we will consider. So in the end, there needs to be an alignment between the industry and the infrastructure managers. So it cannot work differently. Not only one party can determine how the things are going. So RCA will be one input to the system pillar work.
okay, Oliver.
Yeah, basically, Frank already said a lot of true things, so I was lowering my hand. But then I thought about the fact that there was another question in the chat, and maybe we can answer 2 questions in one go, which would be very efficient. So that was, is the methodology we propose, which I presented, also adopted by the system pillar? I can say I don't know. That's what I know where we are, but it's not clear if it becomes exactly this methodology. But of course, we are going to be model-based. We are going to use most probably Capella. The exact modeling framework is just under development. But whatever we do, we have a setup process to process input information and crunch it through our model engine, and then we get output information. And as Frank already said, it's not that we can say, oh, well, RCA is finished, we have to use RCA. They have all the same input, right? And exactly the job of the process is to look at the input information and make conscientious decisions about what from these input information are we going to put into the system pillar. So we have the methodology to decide upon it, and we have the input documents, especially of this context, of course, from RCA, but also from other projects like Okora or Shift to Rail, and they are all treated the same in this mechanism.
Okay, and Roman, you also wanted to say something, I believe. Huh?
Yes. I mean, from the experience of this pre-project that we had to ramp up, we could see that in the scope of CCS, there is not so many areas where we really have conflicting input. So I think this is more a theoretical question. We have a few areas that I know of where we have to discuss really, because we have, for example, from Shift to Rail results that are a bit different, often different terminology, but similar ideas, but you have to find one solution in the end for standard. And for most other areas, there's just more or less only one input that is covering this area, and then often it is coming from RCA, to be honest. And then we should just look at this together, as was said, and then say, okay, is this acceptable for everybody, or do you have in specific issues with it? So should we change something and so on? How does it integrate to the overall architecture? And then we can use it. So it's more this import process and see, yeah, what is there and what can we use and what can be agreed on.
Thank you. This was more or less also what I would like to say about it. So maybe I repeat it a little bit, but I said in the beginning that we have been working in RCA for 5 years. We have invested a lot of time and energy in that. And we have been focusing on CCS, on the track side mainly. Okora did it also. And I think we have really achieved a lot. And there is nobody else, that is what you also say, Roman, there's nobody else who went in so much detail already. And yes, as far as it could be, let me say, checked and seen by the suppliers, they also have said and shown that they appreciate that this is already there and that it is a good starting point. So I'm quite convinced that even though we will not call it RCA anymore, but that is not so important, I'm quite convinced that a lot of the things which have been developed in RCA will just be taken up in the system pillar, worked on further. And from that perspective, I believe that RCA was really a great investment for the EU Links and the EUG members to do, because this is really bringing us steps forward. So also a little bit of a contribution from my side. Now, I believe that we are more or less through the most important questions which were put on the chat, unless I have forgotten that one. But if I have forgotten anything, can you then please raise your hand and say that you would like to have something else addressed? Or can we consider that we have bombarded you with so much information that there is no point in now continuing dwelling on further information? Unless it is the case that Stefan has prohibited you to raise your hand. I do not see any hands. So I would say that then I can consider that to be a confirmation that you have had enough information in this guided tour through RCA. I have noticed that we are decreasing now a little bit with the participants, but at a certain moment we were with 171 participants. And I would imagine that we have to add ourselves as presenters to that. So 180 people in this webinar, which I believe then that also gives an indication that many people have been interested in it. By the way, 260 people have indicated that they anyway want to have the information on it, but they will get it on the www.ertms.be site. Just remember that that little address. Well, I can only hope that you have all, you can come to the conclusion that you got a lot of information and that we helped you further with that, that we, in other words, that we met the expectations which you had prior to clicking on your button to join the thing. So now it's time to stop, to say goodbye to each other. I kindly request the presenters to stay online, and I kindly request the other participants also to quickly click off so that we can have a little chat among ourselves on, do we believe that we did the things right, and so on and so forth. So thank you very much. Have fruitful considerations in the weekend, and see you probably next time.